So in this question, which type of radiation can be stopped by a sheet of paper? So alpha can be stopped by a paper. So that's why A is the right answer. Beta can be stopped by aluminum. Gamma can be stopped by lead. And X-rays also, we can use lead or concrete to stop. So A is the right answer. We use alpha particles. Alpha particles can be stopped by a paper. The second question, a half-life of a radioactive substance is 5 hours. Means after every 5 hours, it will be half of its original value. A sample is tested and found to contain 0.46 gram of a substance. How much of a sample was present 20 hours before it was tested? So right now we have 0.48 of gram of a radioactive sample, like the sample which is emitting out radiation. We want to find how much sample was there radioactive before 20 hours. So how we can work out, because the half-life is 5 hours, so it means after every 5 hours it will be half, and or we can say before every 5 hours it will be double. So before 5 hours, before 5 hours, if it is 0.48 before 5 hours, it should be double of that. So 0.48 times 2 means before 5 hours, it will be 0.96. Then before further 5 hours, it will be double of 0.96. So 0.96 times 2, that is equal to 1.92. Then before further 5 hours, 1.92 times 2, that is equal to 3.84. And before further 5 hours, 3.84 times 2, which is equals to 7.86. So means 7.68. So it means that because the total interval 5 hours, 5, 5 and 5, so total 20 hours. So before 20 hours, how much the sample will be, or what was the sample before 20 hours? That was 7.68. So D will be the right answer. So always remember, after half-life, it will be half of the original value, and before the half-life, it will be double of its original value. Then in question 40, an atom of a lithium contains 3 protons and 3 electrons. The nucleon number is the mass number is 7. What is the neutron? So neutron number is the nucleon number minus the proton number. So 7 minus 3, that's equal to 4. So B will be the right answer. In this question, which line correctly describes the alpha particles? So what are alpha particles? They have a positive charge and penetration 1 centimeter of aluminum means can they pass through aluminum? So they cannot pass through aluminum. So alpha particles are positively charged and they cannot penetrate or pass through aluminum, because if paper can stop alpha, aluminum can definitely stop alpha particles. So alpha particles have lower penetration, they cannot pass through. That's why D is the right answer. In question 39, small amount of radioactive isotope contains 72 billion unstable nuclei. The half-life is 4 hours. How many unstable nuclei would remain after 12 hours? So in the beginning, we have 72 billions of unstable nuclei. Then after half-life, what is a half-life in the question? They mention half-life is 4 hours. That means after 4 hours, out of this 72, half of them will be stable. So say half of 72 will be stable, which is 36. And remaining half will be unstable. Unstable means they are still emitting out radiation. Then these unstable one will further decay after another 4 hours. This 36 will be half. And out of 36, 18 billion will be stable. And 18 will be unstable. So the total time which is passed, 4 hours, so total 8. But we want to find after 12 hours. So after another 4 hours, out of this 18, 9 will be stable and 9 will be unstable. So what is the total duration? 4 hours, 4 and 4. So total duration 12 hours. So means if we start with 72 unstable, if the half-life is 4 hours, so after 12 hours, how many we are left with unstable? So 9 of them will remain as, or 9 billion of them will remain as unstable. Then the next question, how many nucleons are there in a nucleus of potassium? This is a nucleon number. Nucleon number means the sum of neutron and proton. So that nucleon number is 39. So C is the right answer. In this question, which type of radiation has the greatest ionization? The greatest ionization is for alpha. What is the reason for that? Because it is having a greater charge and mass. That's why it causes a greater ionization. So A is the right answer. The 39, a powder contains 400 milligram of a radioactive material that emit out alpha particle. The half-life is 5 days, means after every 5 days it will be half of its original. What mass of a material remain after 10 days? So if we have 400 milligram, what mass of a material remain after 10 days? So basically we want to identify how much is radioactive, and with a half-life of 5 days, so after 5 days, out of 400, 200 milligram will be stable and 200 milligram will be unstable. The stable one does not decay. The unstable one will start to decay more. Then after another 5 days, because the half-life is, according to your question, the half-life 5 days. So after another 5 days, it will be half of its original. So what is half of 200? The half of 200 is 100. So means 100 milligram will be stable and 100 mg or milligram will be. So 100 milligram is stable and 100 milligram will be unstable. So this 100 milligram, which is unstable, will continue to emit out radiation. So that was the question. What mass of a material remain after 10 days? Like what mass of a material is radioactive after 10 days? So we have 100 milligram will be unstable. Then in a symbol below, A is a nucleon number, Z is a proton number. What is represented by the symbol? So this is called a nuclide notation. Nuclide means like atom, notation of an atom. So C is the right answer. The diagram shows 5 atoms are there which are radioactive. The atoms give out alpha particle. So first atom 1 decay, then atom 3 decay. First atom 1 have decayed and then atom 3. Which atom will give out the next particle? So radioactivity is a random process. Random means there is no order, or we cannot predict. So maybe 1 will emit out again, maybe 2 will emit out, maybe 5 will emit out. It's not, there's no order here. So first 1 emit out, then 3 emit out, then there is no order as we mentioned. So we cannot predict, so it is impossible to tell. So we cannot predict which will be the next atom that will decay, as it is a random process which does not have any order. A Geiger counter, which is a detector, record the radiation from a radioactive source, and it is a thick aluminum. So aluminum, as we know, if it was an alpha particle, it will be stopped. If it is a beta particle, it will be stopped. The only radiation which can pass through the aluminum, that is gamma. So alpha will be stopped, beta will be stopped, but gamma will be able to pass through. So which type of radiation from this source is being detected? So we cannot detect alpha, beta, so we can detect gamma radiation. Radioactive radio waves are not the radioactive radiation. That's why it is totally incorrect. So remember, alpha can be stopped by paper, beta can be stopped by aluminum, and gamma can be stopped by lead. So if we place aluminum, it means aluminum will stop both alpha and beta, because alpha cannot pass through paper, so they're not able to pass through aluminum as well. The nucleus of a neutral atom of a lithium is there. How many electron, proton, and neutrons are there in an atom? So atomic number 3, so 3 protons are there. And because it's an atom, so it will have 3 electrons, and neutron 7 minus 3, so that is equals to 4. So proton should be 3, electron should be 3, and neutron should be 4. So D will be the right answer for this. What are the most penetrating? So most penetrating is a gamma. And least penetrating means which travel a shorter distance, that is alpha. So most penetrating is gamma, so either C can be an answer or D, and the least penetrating is alpha, so that's why C is the right answer. Question 39. A radioactive, the half-life of a radioactive substance is 5 hours, means after every 5 hours, the amount of a sample will decrease half of its original, and before every 5 hours, the amount of sample was double of its original. A sample is tested and found to contain 0.48 grams of a substance. How much of a substance was present in the sample 20 hours before the sample tested? So they are asking for before. It means before every 5, because the half-life is 5 hours, so before every 5 hours, the amount should be double. So example, right now we have 0.48 grams of a radioactive sample. So before 5 hours, it should be double of this, so it will be 0.96. Then before another 5 hours, it will be double of this. This is 1.92. Then before further 5 hours, before 5 hours, not further, before 5 hours, it will be double of this, 1.92 times 2, that is 3.84. And before 5 hours, it will be double of this, 7.68. So the total duration, that is 20 hours. So before 20 hours, it was 7.68. So D is the right answer. The data below relate the nucleus of a neutral particle, proton number 7 and nucleon number 17, a number of neutrons and number of electrons. Because it's a neutral particle, so number of electrons should be same as number of proton. So 7, and then number of neutron, the nucleon number minus the proton, so 17 minus 7, which is equals to 10. So A will be the right answer for this. Another question related to atomic physics. What is beta particle? So beta particles are electron, and from which part of a radioactive atom it is emitted out? The source of all the radioactive radiation is the nucleus. Alpha, beta, and gamma all are emitted from the nucleus. What happens inside the nucleus of an atom? That the neutron change to proton and electron, and this electron will go out, and we call this electron as a beta. So what is the source from where it is originated? The source is the nucleus. So all these radiation, all these radioactive radiation such as alpha, beta, and gamma are emitted from the nucleus. So beta is electron, and from where it is emitted out? It is emitted out from the nucleus. Then a sample of a radioactive uranium has a mass of 1 gram. Another sample having a mass of 2 gram. Which property is same for both of the sample? Like in 1 gram and 2 gram, what will be same? The amount of radiation emitted per second, that won't be same, because 2 gram will have more particles, so more radiations will be there. The half-life will be same, half-life is constant. Like example, if 2 gram is there, so if 2 gram is taking say 5 days to convert into 1 gram, same thing, 1 gram will take 5 days to convert into 0.5 grams. So the half-life of a radioactive sample, like if we have a same element, that does not depend on amount of a sample. So half-life is constant for each radioactive material. The number of the uranium atom, that will be different, because 2 grams more mass, so more particles or more atoms will be there. And the volume, 2 gram definitely will occupy more space than 1 gram. So B is the right answer. And in question 40, a particular nuclei has a symbol 17 and 37. What is true for an atom? So it contains 17 protons, it contains 17 electrons, and 37 minus 17. So it contains 20 neutrons. And the nucleon 37 nucleons. So there are 17 nucleons, not 17 nucleons, there are 37 nucleons. There are 17 protons in the nucleus, that is true. So statement B is correct. A radioactive nucleus contains 138 neutron and emit out alpha particle. So when alpha particle emitted out, what will happen? Because when element is there, it emit out alpha particle. If I draw the nucleus, alpha particle means 2 protons and 2 neutrons are coming out. So the neutron number and the proton number, because 2 neutrons are coming out, so neutron number should decrease by 2, and proton number should also decrease by 2. So if originally it was having 138 neutron, if it emit out alpha particle, how many neutrons will be left? Because alpha particle means 2 proton, 2 neutrons. So neutron number also decreased by 2, proton number also decreased by 2. So how many neutrons are there in the nucleus after the alpha is emitted out? So if originally it is 138, and out of 138, if 2 neutrons are going out, So how many we are left with? We are left with 136. So B will be the right answer. The graph shows a decay curve for one particular radioactive nuclide. What is the half-life? So you can take any value. Half-life means time taken by half of the radioactive sample to decay. So I can take any value. Example, if I took 1000, I can also take 2000, the first value. So when I take 2000 as my first value, I'll find the time on x-axis. So this is a third line. So each is representing so this is the third line, each is 0.1, 2, and 3. So this is 0.3. 0.3 days. So when it was 2000, it was 0.3 days. Half of 2000 is 1000. So from 1000, we'll draw a line to identify. So that is 2.3 days. So when it is 1000, it is 2.3 days. So what is the time interval? 2.3 to 0. So the time interval 2.3 minus 0.3, which is equals to 2 days. So half-life of this sample equals to 2 days. So C will be the right answer. And you can take any value. It's not necessary you take 2000. You can take 1000, and half of 1000 will be 500. That does not make difference to the final answer. So when it is 1000, it is 2.3. And then when it is 500, it is 4.3. So this is 2.3. This one is 4.3. So the time interval, that is again 2. So it also takes 2 days to become half of its original value. Then nitrogen isotope is given, which is 16 and 7. How many nucleon are there? Nucleon number, this top number is a nucleon number. So nucleon number, how many nucleons this contains? It contains 16 nucleon. If they ask neutron, then it will be 16 minus 7. So when we compare the alpha particle, the ionizing effect, alpha particles having a greater mass and charge. So they have a greater ionizing effect. So they will have a large ionizing effect. Radiation stopped by aluminum. Yes, if paper can stop alpha, definitely aluminum can also stop alpha. So they have a large ionizing and they can be stopped by even paper, air can stop. So if you place aluminum, definitely it will stop these alpha particles. In question 39, a radioactive substance has a half-life of 2 weeks. Means after every 2 weeks, it becomes half of its original value. Emit out 3000 beta particle per minute. How many beta particle will it emit after 6 weeks? So right now it is emitting out 3000 particles. And the half-life is 2 weeks. So it means after 2 weeks, so how many particles it will emit out? Right now 3000, so it will be 1500. Then after another 2 weeks, that is 750. Then after another 2 weeks, that is 375. So, and why I stop here? Because we want to find after 6 weeks. So after 6 weeks means if the half-life is 2 weeks, so means 3 half-lives are there. So total 6 weeks, after total 6 weeks, the amount of a beta emitting out from the source will left as 375. So B will be the right answer. A nuclide notation for radium is given. How many electrons are there? The number of proton will be equal to number of electron for a neutral atom. 88 protons are there. If it is having 88 proton, to be a neutral atom, it should have 88 electrons as well. So B will be the right answer for this. In question 38, which row shows the relative ionizing effect and penetrating ability of alpha particle and beta particle? Ionizing effect for alpha will be the highest, and penetrating effect, if we are comparing, like comparison is there, the ionizing effects alpha will be more than beta, but penetrating effect, the distance traveled before these radiations stop, so beta can travel more distance than alpha. So ionizing effect alpha should be more than beta, but penetrating effect alpha should be less than, here we can say beta more than alpha or alpha less than beta. So ionizing alpha greater, but penetrating alpha is less. Alpha can be stopped by paper or 4 to 5 centimeter in air. Then a powder contains 400 milligram. So 5 days is a half-life. We want to find after 10 days. So we have 400 milligram. After half-life, we will be 200 milligram will be radioactive. After further half-life, after 10 days, 100 milligram will be radioactive. So C is the right answer. And in question 40, an atom of an element lithium has a nucleon number 7, proton number 3. Which diagram represent a neutral atom of lithium? First, 7 nucleon. So if nucleon number is 7, so how many neutrons is there? 7 minus 3, that's equal to 4 neutron. So which atom contains 4 neutron? 1, 2, 3, 4, this one, and 1, 2, 3, 4, this one. Both are 4. And then because they're saying about the neutral atom, to be a neutral atom, the number of protons should be equal to number of electrons. So here it contains more electrons. This is totally wrong because neutron number is not correct. C and D can be an answer. But why not? Why D is incorrect? Because D contains more electrons than proton. As I mentioned, it's a neutral atom. To be a neutral atom, the number of the protons should be equal to number of electrons. So C should be the right answer for this.